Right, hello everybody, welcome to another video. So the focus on this video is going to be a little bit different from some of my previous videos, in the sense that probably most of my previous videos fall into the category of, this is what the fault was and, this is how I fixed it. In this one I'm going to focus more on the process of how I diagnose faults and, my thinking, the order in which I check things, why I check things in that order, etc. So I'm hoping it'll be maybe a bit more interesting, a bit more informative, and also it will help you kind of like learn what can I say, like a fault finding process that you might be able to start applying to other faults on other cars, rather than just showing you a specific fix on a specific problem on a specific car. So I'm hoping you find it useful and interesting. Obviously, please give me some give feedback. If you like it, give it a thumbs up and the subscribe, and I'll try and do more like this. And I suppose if you don't like it, don't, and I won't. So here we go. Okay, so let's start with the customary introduction of what the car is. So this is a 2006 Ford Fiesta Mk5. This one happens to be the ST model with the 2-litre engine, so that the high performance one. But as I said at the beginning, this video is really about learning and understanding general principles. So what we're discussing today will certainly apply to any Fiesta, not just this version, and as I hope will become apparent, it will apply to most cars. In fact, not just Fiestas. There's actually a few things wrong with this car. As you can see here, I'm halfway through changing the window regulator on this driver's door. I'm not going to be doing a video on that because I've actually found a very good video which I actually myself relied on to do this job. So I'm going to put a link for that video in the description. So if you do happen to be after info on that, check that video out. It's also got a knock from the exhaust, which is coming from down there somewhere. So we'll check that out in a video in the future probably, and fix that. Maybe in the same sort of like process as this one. Discussing the how I go about kind of like diagnosing. But anyway, after that long intro, let's get on to what the problem with this car actually is. So if I switch on the ignition and just give it a moment, as you can see, it says, well, it says bonnet open, but also it says low outside temperature, minus 38 degrees Celsius, and it's also got this ice warning symbol, and I think this orange light here is lighting in conjunction with that. So as you can probably guess, we're not in like Siberia or something. We're in the UK, and we don't always have the best summers here, but it is actually quite a nice day today. I'm wearing shorts, as you can see. It's certainly not minus 38 degrees, so that's obviously incorrect, and basically that's what we're going to talk about sorting out. So okay, so we got this reading of minus 38 degrees showing on there, which we know to be wrong. So I suppose as a starting point, we could think, well, what are the things that could be faulty here? I mean, there's obviously a sensor somewhere, so that could be faulty. The wiring to the sensor could be faulty, or of course the display unit here, that could be faulty. Now, just based on my knowledge of like car electronics, which I'm going to sort of talk electrics and electronics, so which I'm going to sort of talk through now, I'm almost certain, just based on that reading of minus 38 degrees, that this fault has got nothing to do with this display unit or any of the electronics in there. That this fault is almost certainly due to either a break in the wire going to the sensor, to the outside temperature sensor, or a complete open, a completely blown sensor. Now the reason I know that, and I'm guessing some of you watching this video will also know that, the reason I know that is because most temperature sensors on most cars are what are known as negative temperature coefficient thermistors. Now, a thermistor is a resistor whose resistance varies with temperature, and the negative temperature coefficient bit means that as the temperature goes up, the resistance goes down, and as the temperature goes down, the resistance goes up. So basically, that very low temperature reading there is I know is corresponding to a very, very high resistance in that circuit. And actually, I know from previous experience on cars in general that you get that reading when either the sensor has either been unplugged or there's a break in the sensor, or it's like completely blown in the sensor. There's no electrical continuity through the sensor anymore. So yeah, so based on that, I'm gonna ignore the possibility of there being any fault here, because I'm 99% certain that's not the case. So we're gonna focus on the wiring basically, or the temperature sensor itself. Now, just quickly, I suppose some of you might be thinking, well, what about the fuse? So, because obviously, if one suspects, say, a break in a circuit, that break could obviously be at the fuse. It could be a blown fuse. For certain components at this point, I would now be sort of like going to check the fuse maybe, but in this instance, I'm not going to be trying to check any fuses, because I know, just again, not from particular experience with this model, but just my general experience of cars, that this component is not going to have its own fuse. This component is going to be powered by is going to be connected either to the engine computer, or maybe to like a body control computer, something like that. So it's effectively going to get fused through a unit like that. It's not going to have its own fuse. So for that reason, I'm not going to be checking any fuses. So my first thing I'm going to do, which is why I got the bonnet open, is I'm going to go and do a locate the sensor, and then find and do a visual inspection of the sensor and the wiring to it. Okay, so I've located the sensor. It's just here. And I'll just talk a little bit about how I located it. Obviously, I mean, one way of doing it is just to kind of do a search on the internet. But I know just from previous experience that these sensors, they nearly always go on the front bumper somewhere, reasonably low down. These outside temperature sensors. I think the reason for that is because if they were anywhere either further up or further but towards the back of the car, you'd get problems with heat soak from the engine and the rest of the car, affecting the temperature reading. So that's why I happen to know that they're always on the front bumper somewhere, fairly low down. So what I did was I had a look through the grille initially, and I just managed to see the wiring. And then I saw this wiring and this connector, and then actually what I did, this is a good tip actually, I think. So I saw this wiring and this connector, but like I said, I've never done one of these before, so I suspected this was the outside temperature sensor, but I wasn't sure. And before taking this grill off and stuff, I really wanted to be sure. So what I did is I just went on eBay and I did a search for Fiesta Mk5 outside temperature sensor, something like that, and I saw that the pictures of the sensors that came up, they had these two black wires and this grey connector. So that's why, before going to the trouble of taking this grill off, I was able to sort of make sure that I was on the correct sensor. So yeah, so just in terms of taking this grill off, by the way, this bit that's broken here, that wasn't me. I always take these things off carefully, and just to let you know, in case you are taking one of these things off, there's no screws or anything, they just clip on, and what you want to do to release it is just to gently, either from the front or from the, better still, like at the bottom, you can get them from the back, kind of like push these clips away from this blue bumper bit, and then carefully pull it out. don't just yank it out, otherwise you'll break it. So I'm not sure whether this car's been like a very light knock here, or maybe someone's previously like carelessly tried to remove this. But either way, it wasn't me. Okay guys, so I've got the connector unplugged. So this is the connector, this is the actual sensor bit. So first of all, just want to make sure that we've got a power and ground here. So I'm going to put my voltmeter on a 20 volt scale, and I'm just without sort of pushing these all the way in, I'm just gently going to touch the terminals. As you can see, we've got a just under 11 volt reading there. Oops. Sorry about the change in reading. That's just because I don't want to push these pins too far and spread these terminals. So I'm just sort of trying to hold it there lightly. But as you can see, we've got just under 11 volt, which is fine. Basically, we just want to make sure we've got a power and ground there. But actually, hang on, I'm just going to go and switch off the ignition because I don't want to fasten the battery too much. But actually, on this, when we do a resistance check on this sensor, so I've got it on the ohm scale now, my volt ohm meter. Now I was expecting to find this to be completely open, but it's actually not. It's a little bit difficult to do, but I'll just try and show you, because I already just did this quickly off camera earlier, so I'll just try and show you. So see, we've got a 10 ohm resistance there. Now, as I said earlier, I was expecting this to be completely open, like, you know, I was expecting instead for it just to be showing like an open symbol like that one, not this 10 ohm reading. So I'm actually a little bit confused what's going on at the moment. So that could still be a much higher resistance than what it should be, which is why I suspect it is, which is why that temperature reading is reading so low. So what I'm going to have to do is go and find out what the resistance value should be, and then take it from there. Alright, so quick correction, I misspoke slightly in the earlier clip. I referred to the resistance value as being 10 ohms. What I should have said, even though it was reading 10 on the display here, I had it on a kilo ohm scale, so that was actually 10 kilo ohms. So just to correct that. I've got so just to let you know, I've had a look on the internet to try and get some resistance specs for this. I've actually, as well as the internet, I've actually looked in a Haynes manual, and also in an old copy of auto data that I got loaded on my computer, and to my surprise, I haven't been able to get some you know, the resistance specs for this. But having said that, just you know, I'm sort of like fairly confident that it shouldn't be this high. I think the operating range should be maybe like somewhere from like the high hundreds of ohms to maybe the very low kilo ohms. So the fact that this is on 10 kilo ohms, I'm fairly confident that's a very, very high resistance. It's much higher than what it should be. What I'm also going to do is I've got a hairdryer here, so I'm going to try heating it up. In fact, I've already done it, but I'm just going to do it again to show you, and to show that resistance value isn't going to change when we heat it up. So that was actually hot enough to be sort of like almost burning my hand there where I had it down there like that. And as you can see, the resistance value just did not change at all. So I think if this was a more expensive component, I would probably kind of like, you know, spend some more time and get the actual definite resistance specs. But seeing as these components are quite cheap anyway, that I think they're only about just over £10, I'm just going to go ahead and get a replacement. And when I get the replacement, which you will see on the next scene of the video, I will sort of hook it back up like this to do a comparison. So I'm pretty sure on the new one we'll see that the resistance value will be much lower and will change when we heat it up with a hairdryer. So yep, that's what I'm going to go ahead and do, and I will see you guys. Well, it'll be a few days for me, but for you it will be in the next scene. Right, so it's a couple of days later, and I got a replacement second-hand genuine outside air temperature sensor. I could have got a new aftermarket one for about the same price. I paid £10 for this delivered off of eBay. Could have got a like I said, could have got a non-genuine new one for about the same price, but unfortunately a lot of the time these non-genuine parts can be pretty poor quality, unfortunately. So I was a bit like that, but in the end I decided to go for the second-hand genuine one instead. So anyway, got it set up exactly like it was, like we had the other one in the last clip, and as you can see, that resistance value straight away much lower than the other one. I'm just trying to think, because it's a couple of days later for me, but I think the other one was reading 10 kilo ohms, wasn't it? So 10 plus kilo ohms. This one's under 3, and again we did the heat up test on the other one, and it didn't move at all, did it? So so we're going to do the same heat up test to compare. Again, I've already done it, so I know what's going to happen. The resistance is going to go down on this one, so I'll just show you. As you can see, straight away it starts going down. It's going down. Keeps going down. Still going down. I'll stop there because I don't want to overheat it. But as you can see, when I've stopped, it's still going down a little bit because of the heat soak. But as you see, that will stabilise off in a second. There you go, stop going down. And then it will now slowly start going back up. So whilst we're just waiting for that to go back up, I'll just say about this meter I've got here. This is only a cheap meter. I think I paid about £15 for it. I've had it quite a few years, and I've got to say, if you haven't got one, like a meter like this, you know, you need to get one, because they're for how cheap they are. Because you can get them for less than £10. Obviously, you can get better quality ones for a lot more than that. But you know, really, like I said, this is a cheap one, and for such a cheap tool, they're really useful. So you know, if you haven't got one already, I would really recommend getting one. You will not regret getting one of these. I promise. Well, assuming you're the sort of person who likes fixing things and that kind of thing, and understanding how things work. But obviously, if you're watching this video, I'm assuming you are. So if you haven't already got one of these meters, get one. I don't know what make this is. That's what it says on there, DT8830B. But it's not got a brand on it as such. But anyway, I would just get any one. Don't procrastinate over it. Just get one. They're so cheap and they're so useful. So as you can see, anyway, I was babbling on there just to sort of let the resistance come back up a bit. So it's slowly coming back up, as you can see, and I can confirm from when I did it earlier, before I started filming, that it will go back up to just under 3 ohms. Sorry, 3 kilo ohms. I keep getting my ohms and my kilo ohms mixed up. I'll keep going up to just under 3 kilo ohms. We won't let that go all the way back up. You can see that it is doing that. So anyway, I'm pretty sure this is going to fix our problem. So let's go to the car, or I'll go to the car, put this on, and hopefully come back to you with the clip confirming that it's fixed. Right, sensor installed and ignition on, and as you can see it's now reading 15 degrees Celsius, which is correct. That is about the temperature today. So that's the fix basically. So hope that was all interesting to you, and thank you for watching, and hope to catch you on the next video soon.